On a world 640 light-years from Earth, it does not rain water, but molten iron. This is WASP-76b, a place where the atmosphere itself is a chaotic forge, vaporizing metals on one side and dripping them as liquid metal rain on the other. It is an environment so hostile and alien that it challenges our fundamental understanding of planetary science. Here, the boundaries between astronomy and extreme chemistry blur under the relentless glare of a nearby star. This gas giant is not merely hot, it represents an entirely new class of worlds known as ultra-hot Jupiters, where the laws of weather are rewritten in iron and fire. Discovered in 2016 by the Wide-Angle Search for Planets Consortium, WASP-76b was identified as it crossed the face of its parent star, a yellow-white dwarf slightly larger and hotter than our Sun in the constellation of Pisces. By measuring the tiny dip in starlight as the planet passed by, astronomers mapped its orbital path. The results were staggering. This giant world, which contains nearly the mass of Jupiter but is puffed up to almost double its physical size, orbits its star at a distance of just 5 million kilometers. This is less than 2% of the distance between the Earth and the Sun. At this extreme proximity, a single year on WASP-76b, one complete journey around its star, lasts a mere 1.8 Earth days. This incredibly tight orbit has forced the planet into a state of tidal locking. Just as the Moon always shows the same face to Earth, WASP-76b is gravitationally locked to its star, meaning one hemisphere experiences eternal, blinding day, while the other is plunged into everlasting night. If you stood at the boundary line between these two halves, you would see a star that never rises or sets, hanging forever on the horizon as a colossal, swollen furnace. On the perpetual day side, temperatures soar to an unimaginable 2400 degrees Celsius. This is hot enough to melt titanium, liquefy platinum, and tear molecules of water apart into individual atoms. At these temperatures, iron does not merely melt, it boils, turning into a metallic vapor that rises into the planet's puffed-up hydrogen atmosphere. Meanwhile, the night side of the planet, though shielded from the star's direct radiation, remains a hellish 1500 degrees Celsius. This profound temperature difference of nearly 1000 degrees between the two hemispheres drives monstrous atmospheric currents. Supersonic winds sweep across the planet at speeds exceeding 18,000 kilometers per hour, which is 15 times faster than the speed of sound on Earth. If you were somehow suspended in these winds, your body would be instantly shredded and dispersed into the rushing gas. These winds carry the vaporized iron from the blazing day side toward the cooler night side. As the gas crosses the evening terminator, the boundary line between day and night, the temperature drops sharply. The iron vapor cools rapidly, condensing into metallic clouds that release a relentless torrent of liquid iron rain, screaming downward through the dark, turbulent atmosphere. Scientists detected this bizarre weather cycle using the espresso spectrograph mounted on the European Southern Observatory's Very Large Telescope in Chile. By analyzing the starlight filtering through the edges of the planet's atmosphere, they noticed a strong signature of iron vapor at the evening border, but none at the morning border. This proved that iron was actively vaporizing on the day side, blowing east, and condensing into liquid rain as it crossed into the night. Yet, WASP-76b still harbors profound mysteries that continue to puzzle astronomers. In 2024, observations from the European Space Agency's Cheops Space Telescope revealed an unexpected glow coming from the eastern terminator of the planet. This signal is believed to be a rare, rainbow-like optical phenomenon characterized by concentric, colorful rings of light. On Earth, glories are common when sunlight scatters off uniform droplets of mist, often seen from airplanes. But for a glory to occur on WASP-76b, the atmosphere must contain perfectly spherical droplets that remain incredibly stable over time. How such delicate, uniform droplets can persist in an atmosphere churned by supersonic winds and extreme thermal gradients remains a deep mystery. Furthermore, the planet is far more bloated than standard thermodynamic models can explain, suggesting some unknown internal heating mechanism is inflating its gas envelope like a hot air balloon. These unexplained features remind us that our journey into the cosmos is still in its infancy. WASP-76b is a stark testament to the sheer diversity of the universe. It proves that nature can construct worlds out of the same basic elements found in our solar system, yet arrange them into configurations that defy our imagination. Everything you have ever seen on Earth, from the gentle cycle of water to the solid, predictable ground beneath your feet, is but a tiny, quiet exception in a cosmos that thrives on the extreme. In studying this ion-soaked giant, we do not just learn about a distant world, we glimpse the raw, unbridled power of cosmic physics, operating on a scale that humbles our understanding of reality.